Good day, students. My name is Mrs. Onome Okoye. I'm here once again to take you through this revision class. Today we are going to look at introduction to practicals, some of the tips that you need to know while carrying out practicals, because we discover that a lot of students don't follow some of the principles or the things they need to know for practical work. So with the few tips I'm going to give to you, I'm sure it will help you better in your practical work. Introduction. The procedure to be followed in carrying out the experiment is usually laid out in the question paper, because it is your question paper that directs you on what to do. And in your question paper, like I always advise my students, you follow the instruction one at a time. Don't try to go to instruction 3 when you have not finished with instruction 1. So follow the instruction one after the other. So for convenience of grading, your answer is broken down or into sections. We have different sections that is broken down into. We have the observation, we have graph, we have slope, deductions, intercept, evaluation or calculation, precautions, and short answer theory question. Now, the whole of the practical work, we have about 3 questions for you to answer to, and each of the questions carries 25 marks. So 2 questions out of the 3 gives you 50 marks, which is a whole lot of marks. So we advise that students should be very, very careful, because if you can score 50 in your practical work, that means you are good to go, because you have theory and objective. So little effort in your theory and objective, wow, bravo, you are gone, right? So the first part is your observation. Now, what is involved in your observation? That has to do with your table of values. And your table of values is formed from the question, from the question given to you. And each of them, will have different columns. And observation is expected to be done in one continuous table, which is called composite table. For instance, how do I mean? Composite table is a table where all your values are together. Now, maybe you're trying to form your table, you made a mistake on one column, maybe you strike that column off, you go to another page to write that column. You have broken that table. And because of that, you will lose 1 mark. That 1 mark is for the composite table. You will lose 1 mark for composite table. So it is advised that when you are writing your table or forming your table, all of them should be in one continuous, unbroken table, which is called composite table. Now, in practical, for instance, there are a lot of things that you must take note of, because every half mark counts a lot. On that table, for instance, maybe from the question, you have L is on your table, which is, we have L, maybe you have T, that's time, you have period. Now, as you label your table, you write your L, you put the unit, because if you don't put the unit, you will lose half mark for no unit or wrong unit. So for every column, after you have written your values, you put that's the variables that is needed on that table, you put your units, because for every column that have no unit is minus half mark. And if maybe you minus half mark from every column, you discover that all your marks will be gone. So we should be very careful when we are writing our tables. Now, also another thing that we need to take note of in our table, we have what is called DPs and significant figures. Now, maybe from the question you are asked to record L, and they gave you from the question as L equal to 100 centimeters, 90 centimeters, 80 centimeters, 70 as the case may be. And you just come to your table and you just write it as 70. 100, 90, 80, 70 as given to you from the question. At the end of the day, you may fail it, even though it's correct. The reason is that it's not to a decimal point. So such a column is to at least 1 DP. So, but if you fail to put the decimal point, you see yourself losing mark for that column. And at the end, you feel that, what happened? I did very well, all my scores were correct, my values were correct, and all that. And another thing we talk about in practical is every child that, maybe in a class now, you're carrying out practical, everybody to their own stand. You do not need to bother yourself with the values of the other person close to you. Because practical work is that you are the one supplying the values for the examiner to mark. So if you're second, maybe the same experiment you have carried out, you are getting maybe 40, and the other person is getting 35 or 30 something, and you are bothered, why is your own 30 something and my own is 40, and you begin to break your head over, scores or values like that. There's no need for that, because the examiner will score you based on your information that you provide. And again, the only thing that you need to take note of is the trend. There must be a trend. So moving on, I want to give us some sources of general penalty. Let's take note of general penalty while carrying out practicals. 1, wrong unit or missing unit attract loss of half mark. If there is no unit and your unit is wrong, it attracts loss of half mark. Units may be stated in table or in graph. If the unit is stated in table and is not stated in graph, you don't penalize, you can still mark. But there's no loss of mark when it comes to derived unit. Another area where you will lose mark is inconsistent significant figure or decimal point. How do we mean by inconsistent? Maybe your first value is 3.56. The next one, you write 3.5. The other one, you write 3.67. You can see that it's not consistent. So by so doing, you'll be losing half mark. But per column, you will lose like 1 mark. The same thing, if maybe that column, you are supposed to put it to 2 DPs, and you are writing it to 1 DP, and your values are correct. The values are correct, quite all right. But because it's not to the decimal point that is required by the examiner, you will fail it. You score 0 for nothing, right? So, inconsistent significant figure or decimal point attract loss of half mark per column and to a total maximum of 1 mark per table. So, moving on, systematic error. We have what we call systematic error. Systematic error gives you, or you lose 1 mark for systematic errors. Now, disregard of instruction. We have what is called disregard of instruction. When you do not follow the instruction given to you, you will lose 1 mark for that. Then we have gross error. For instance, you are asked to measure glancing angles. You measure angles of incident. So you lose the whole marks for that column, that is allotted to that column. And also for graph, you lose mark for graph except for axis distinguished. So you have to be very careful. Follow instructions as they come. Now, quantities read from table. For instance, there are some quantities that will be that are read from the table or recorded from table. Such quantities are recorded to at least 3 decimal places. 3 decimal places, like reciprocals, logs, square root. They are recorded to 3 decimal places. Nobody will tell you that, and that's the reason why, you have this opportunity. Maybe some of us in our various schools, our teachers have told us about that, and there are even some schools where they've not started practicals at all. So for those of us who have not done that, you still have a good opportunity to learn something from what we are doing today. So if that column is supposed to be to 3 DPs and you record to 2 DPs, you fail everything. In spite of the fact that your values are correct, you fail everything, you lose the mark for that. If the mark is 1 mark, you lose that 1 mark for that column. And except for exact values, is permitted. Otherwise, you lose that mark for that. Then we have short questions. That's the B part of the practical, where you have the theory part. That gives you about 4 marks. 4 marks for that. So in that theory part, there is lots of half mark for wrong unit or no unit. Wrong unit or no unit gives you, that you lose half mark for the final answer of that numerical problem. So I've been able to tell us some of the areas where you are expected to lose marks. Now moving on, after observation, the next step is your graph. The next step is your graph. Graph gives you a total of 5 to 6 marks, which is a whole lot. Now observation, for instance, the marks varies from 8, 9, 10, 11. That's just for your table. It's a whole lot of marks. I know that practical work is 25 marks. So if you can secure 25 marks each from the 2 practical work, you are good to go. So graph work is 6 marks. Now how do you begin? The first thing you do for your graph is you label the graph. Label the graph. How do you label the graph? Maybe the question says plot a graph of A against B. So when you come to your graph, we are not interested in you telling us X and Y axis as in mass. Tell us, what did the question say in your X axis? What are you supposed to write there? You write it with the unit, then you go to your Y axis, you label it also with the unit. If you do that correctly, you score 1 mark, or each of them is half mark. Half mark, that gives you 1 mark. After you have done that, you choose a reasonable scale. You choose a reasonable scale. And how do you know a scale that is reasonable? The scale must occupy at least half of the page or the space provided. It must occupy at least half of the space or the page that is provided. Now note that scales like multiple scales or sub-multiples of prime numbers, such as 3, 7, 11, 13, they are not acceptable. They are not acceptable. So your scale must be reasonable. And origin is also part of it if requested. You know, there are some questions that say starting your axis from 0, 0. So that's the origin. So if it is stated, you must start from 0, 0. Otherwise, you lose mark also. And in case of intercept, you start from the origin. Now, after you have done that, the next step is for you to plot your graph correctly. That is, using the values from your table. Plot it correctly. Don't try to manipulate. Or do not even try to copy somebody's work, because your values may be different from that person's value. So do not try to look at another person's value and plot. If your the graph can accommodate your values, do not approximate. Plot it as it is. Because it is the examiner will look at your values and still plot the graph. So if you try to manipulate, the examiner will know, because the way you have plotted, that's how the examiner will look at your value and plot. So if it's not correctly plotted, you lose mark for that. All right? After you have done that, the line of best fit. We have what is called line of best fit. Now, how do you obtain a suitable line of best fit? At least the three points that you have plotted must be correct. You know, the line of best fit, that line you draw to join your points. 3 points must be correctly plotted. And the other 2, if you have maybe 5 points, 3 correctly plotted. If all of them enters, fine, bravo. But otherwise, the other 2 may spread out, maybe fall out of the line on both sides. Then you get your line of best fit, which is 1 mark. So after you have done, there's something we also consider. We talk about match point. You know, there are some students, what they just have on their table, they just lift it to the graph and they just match it, and they have a beautiful straight line graph and they are happy. Ah, wow, yes. I don't kill them. No, that is what we call match point. When you do that, you fail everything on that graph. You fail everything. The only thing you will get is the value for axis distinguished. That means you fail the plotting, you fail for slope, you will fail for deductions or intercept, as the case may be. So match point, run away from it. Because students are looking for a way out, easy out. They just think that when you are plotting, it's not like math. I don't know how it is, but like physics, your line of best fit may not be from the origin, can be from anywhere. So when it's not cutting through your origin, you want to kill your head, you want to break yourself. My arm must cut. So you see students trying to bend their ruler, manipulate their rulers and all that. So all of that is not necessary. Okay, having done that, there are some cases where candidate plots unwanted variables. It's not on their table. They just bring anything, any value from anywhere. They just plot their table and they go. It's not proper. That's gross error. So you score 0 for graph in that case. All right. After you have drawn your graph, the next thing is to take your slope. Slope gives you about 2 marks. Somebody say, 2 marks, small now. No, every mark is very important. So slope, the first thing you do is to draw a large right angle triangle. Your angle must be large. The triangle must be large. Now, at times, you see students trying to look for points, 2 points where they can just draw and they get 2 small points. They just draw it so that they can look at their notes or their table, the values they can just bring out and evaluate. No, it's not important. You can take your slope from any point in the graph, provided it is large and you can read it. If you can read your graph, there's no problem about that. So large angle triangle gives you at least half mark first. Then you look for, the next thing is to get the x. The x1 correctly read and recorded. When you draw your graph, you look for the values on the x-axis and the value on the y-axis. If they are correctly read and calculated, you score half mark for each of them. The last one, if it's correctly evaluated, that's the x over the y, correctly calculated, you get the other half mark. For instance, your dx is correct and your dy is wrong, then the evaluation of the x dy is correct. We have what we call follow through. Even though you have failed, we don't transfer penalty. Even though you have failed at a point, you continue with that wrong values and you get the answer for the last part of the y, the x, you still get a score for that. So that is that for practical, for slope, which gives you 2 marks. Now after which, we have what's called evaluation. Maybe you are asked to evaluate something from the graph. Maybe k equal to 4 pi squared over s, where s is the slope. So what do? Correct substitution gives you half mark, then correct answer gives you another half mark. Because the formula is there already. So it's just for you to substitute correctly and get your correct answer. That gives you another half mark. That's a total of 1 mark. Then there are some cases where we have accuracy. When we talk about accuracy, for instance, it says look for the value of k in that evaluation. K may mean the mass of the ruler that is supplied by the teacher. So if the mass of the ruler supplied by the teacher, the value is plus or minus 10% of the 10% plus or minus 10% of the value the teacher supplied, and your k, the value of your k is corresponding to it, you get that 1 mark. Otherwise, if the teacher did not supply the value for the mass of the ruler, then the child scores 0 there. Now that takes us to the last part of the practical work, precaution. Every practical has precaution. That is why you were carrying out the practical. What were the precautions you considered? And precautions are stated in acceptable language. Now, when they say state precaution, you say, 1, avoid parallax error. Yes, it sounds correct, avoid parallax error. But it's like you are commanding the examiner, avoid parallax error. Am I the one that did the practical? You are the one that did the practical. So tell us what you did. So the best way to put such is, I avoided parallax error. Now, if you still end by saying I avoided parallax error, you will still fail it. Why? Because you did not mention the instrument used in that practical. For instance, maybe you are carrying out practical on simple pendulum. You have a meter rule, you have a stopwatch. So you will state it as, I avoided parallax error when reading the meter rule or when reading the stopwatch or clock. So the instrument must be mentioned for you to get that mark correctly. Of course, in every practical, they will ask you to state 2 precautions. And those 2 precautions gives you a total mark of 2 marks. So you state the precaution in the acceptable language. So if you can do that correctly, I avoid, I ensure. So also for, you ensure or note 0 error and correct it. You know, for like stopwatch, you note the 0 error, you correct it. I ensure I noted 0 error and corrected the of the meter rule or the stopwatch of the stopwatch. Or in electricity can be voltmeter, ammeter, as the case may be. So you must mention the instrument when you are talking about parallax error and 0 error. Mention the instrument for you to get the full mark for that. So after you have done this, the next aspect is the theory part. That theory part, by the time you get to precaution, the total marks for that is 21 marks. So the theory part gives you the extra 4 marks. That makes it 25 marks. So I know that I've not been able to, express myself so well because, when you are seeing a live, when you are plotting the graph live, somebody will be able to correct you and that will help you better. But with what I have been able to pass across to you, I'm sure it will help you a great deal. Now, I want to give us some precautions, the way you should state precautions in different practical. For instance, the simple, that's the Mechanism, simple pendulum practical, and also for principles of moment. The precautions are like avoided error due to parallax when reading the meter rule or stopwatch. 2, avoided drought. Now, drought is very important. We don't use air. If you say avoided air, you will fail it. We don't mention air. Instead, you write drought. D-R-O-A, not D-R-O-O, as the case may be. So D-R-O-A-U-G-H-T, avoided drought. Avoided conical oscillations. I ensure I repeated readings. Now, for this one, when you mention repeated readings, for you to get the marks, it must be shown on your table. You cannot tell us that you ensure repeated readings and it's not showing on your table. If it's not showing on your table, you will fail the mark for that. You won't get the mark. But in any case, maybe you are asked to state 2 precautions. You get one correctly, you fail the other one, and you repeated your readings on your table. Because it's on your table, you can still score that 1 mark. So take note of that. When you're writing repeated readings, it must be shown on your table. I made sure I noted or corrected 0 error of the meter rule or of the stopwatch or of the stop clock. Like I said, you must mention the instrument. Then another one that you can state, because I'm taking simple pendulum and the moment together, avoided mass touching table or the floor. Okay? Then for light, you can say I ensure neat traces. Now the neat traces is that it must be seen on your trace. Don't just say I ensure neat traces and your traces, is stained, is not neat, so you won't get that mark. So when you say neat traces, it must be shown on your tracing paper. So I ensure reasonable spacing, that one is true. Then I ensure pins are vertical and upright, and avoided parallax error too in reading protractor. That's for heat, or that's for light experiment, protractor. We use protractor when we're talking about prism, triangular and rectangular prism. So in all, you make sure you mention the instrument. Then maybe for like electricity, you can say I ensure tight connections or clean terminals. Tight connection and clean terminals gives you 1 mark. I ensure I noted and corrected 0 error of the meter rule stroke voltmeter. Like I said, you mentioned the instrument. Then parallax error when reading the ammeter or meter rule. Then the key is open when readings are not taken. These are some of the possible precautions that you can state while carrying out the practicals. I want to thank you for listening. I want to believe that at the end of this whole section, you must have gained something. Even if it's small, you have gained something. And I want to advise that now that we're at home, don't just while away your time. Don't just play out your time. Read your books, because the moment the whole exercise is over, it's you and your exam. So please get close to your books, especially those of you in sciences. You understand what I'm talking about. So please get close to your books, read your books, and I know that God will help you a great day. Thank you so much.
I'm Mrs. Ogala by name, basic science teacher. I'm here to revise with you topic known as pollution. Pollution is a release of unwanted materials into the environment which can cause harm to humans, animals, and plants in the environment. Pollution, we have different types of pollution. We have the air pollution, water pollution, soil pollution, which is also known as land pollution, and we have noise pollution. These are the types of pollution we have in our environment. Air pollution is as a release of unwanted material to the environment which causes harms to animals and plants in the environment. And what are the causes of this air pollution? We have number one, road construction. As a result of construction of road, we have dust all over the environment, which can now cause air pollution to the environment. And number two causes is as a result of burning of wood, coals. Number three, we have decay organic matters. For instance, in our environment, you see people dropping dustbin, perishable things in the environment as a result of decaying animals in this our environment. You find out that the whole environment is being polluted with this decay organic matters. Another causes of air pollution is overcrowding in a bedroom. You find out that in a bedroom, 8 people are living in one room. So the room will be overcrowded, and so there will be no enough air in that room. And this can lead to what? Air pollution. And number 5 causes is exhaust pipe of unserviced engine. For example, you see some of our vehicles that are not serviced. You see smoke coming out from the exhaust of a car because the car is not serviced. And that exhaust coming out from the car is known as carbon dioxide, which is known as air pollution to the environment. And so this causes of air pollution to our environment is not conducive for us. Even when you go to some factories, you discover that the engines used for production of their products pollute the air. And some other causes again is water from our soakaways and all the rest, dirty gutters. This leads to what? Air pollution. And we have causes of water pollution. Water pollution. How is water being polluted? Water can be polluted as a result of over-fertilizer in our lands. And when it rains, this fertilizer that is being applied on a large amount on the farm will be washed into our river streams. At the end of the day, the water is being polluted. Or trying to fertilize the plants so that crops will yield fine. This can still cause what is known as air pollution. And we have the causes. Number one, industrial waste. Waste from the industries are one of the causes of water pollution. And number two, domestic waste. Just like I said earlier on, the water from our bathroom, soakaways, that is being flushed to the gutters, and at the end of the day, when it rains, the water from the waters will be flushed into our rivers and streams. At the end of the day, the water is being polluted. That is domestic waste. Agricultural waste, just as I said, fertilizer being applied on a large amount on our farm products. And when it rains, it's being flushed into the rivers. The water will be polluted. Then also oil spillage. Oil spillage is one of the causes of what? Water pollution. When it rains, all the oil that is on the land will be flushed down into the river and thereby polluting our water. Just like where we have pipelines, and when these pipelines are being destroyed, the water in that area is being polluted and it will not be useful to them again. Animals walking through the rivers, like the cattle railers, they carry their cattle down to the stream to drink water. So as the cattle are drinking water, they are urinating there, defecating there, and at the end of the day, the water is being polluted. The water is being polluted. And so, like I said earlier on, oil spillage, which is one of the causes of water pollution. Oil spillage is the accidental escape of oil from damaged oil pipelines, and as well, or deliberate discharge of oil into an environment. That is what oil spillage is all about. And so we have the causes of this oil spillage in our lands or soils. One of the causes of oil spillage is damaged oil tankers. You see these tankers, some of them are being damaged. At the end of the day, the oil is being littered all over the land. Causes what? Water pollution. Another one again is breaking of pipelines to steal fuel. Our boys today, you see them, they want to make money. They go over there where these pipelines are being laid down. They destroy it just to steal fuel from the pipelines. This is one of the causes of oil spillage in our environment. And number three, explosion from oil well. When an explosion comes like this in oil well, you see oil being littered all over the land. Another causes of oil spillage is sabotage by agitating youths. Youth don't want to take what the government are saying. They want to do what is in their mind, thereby going there to destroy the pipelines and causing what? Oil spillage. At the end of the day, the soil is being polluted, or the land like I said, the soil is known as land pollution. And so this spillage, oil spillage, destroys lands, and at the end of the day, the oil is being washed into our waters, making this water to be unfit for drinking or for use. And one of the effects of this oil spillage is to make farmland unfit for farming. Those people that live in the riverine area, you find out that this oil spillage is being littered all over their farmlands. They cannot farm because of oil spillage. Another causes again is caused by people. It causes people to lose their job. Once there is oil spillage, many people lose their job. Just like if there's an explosion in oil well, most people that are working there, they will lose their job. Another one again is it kills living organisms in the water. Oil spillage, one of the effects is that the organisms that are living in the water will be destroyed, like our fishes in the water. They will be destroyed because of this oil spillage. Another one again, it makes water unfit for drinking. Once the water is being polluted by oil, there is no way the water will be fit for drinking. These are the effects of oil spillage in our water. And so with this, and I believe that you should be able to know what pollution is all about in our environment. And if you are asked to list the types of pollution that we have in our environment, I believe you'll be able to do that. And I know with this revision, you'll be able to answer questions under this pollution. And again, you should be able to know the causes of pollution. What causes air pollution, water pollution, land pollution, and so forth. And also the oil spillage, the causes of oil spillage in our environment, and the effect of this oil spillage. And I believe you understand all what we have said so far. So now let's talk on a topic, habitat again. Habitat is a place in nature where an organism lives. Habitat is a place in nature where organisms live. And so we have different types of habitats. We have aquatic habitats, which is also known as water habitats. Aquatic habitat is also known as what? Water habitat. And in this aquatic habitat, there are three types of habitats. Number one is freshwater habitat. Number one is freshwater habitat. And then number two, we have the marine habitat. And then estuarine habitat. These are the three habitats that are in aquatic habitat. The freshwater habitat is an environment where the water is fresh, and organisms that live there are, we have the crabs. The crabs are organisms that live in freshwater habitat. Example of freshwater habitat, we have the rivers, the streams, the pond, the spring. And so the organisms that live there are, example, crabs, water snail, and tadpole. These are the organisms that live in freshwater habitat. And then the next one, which is marine habitat, is very high in salt. The water there is very high, is a salty water. The marine habitat is a salty water. And there you find that the concentration of salt is very high. Example of such place, we have the sea, the ocean. These are examples of what? Marine habitat. And we have organisms that live there, like the whale, the dolphins, the shark, and so on. These are the animals that live in marine habitat. The estuarine habitat is a mixture of salty water and fresh water. A mixture of what? Salty water and fresh water. Example of this place is known as lagoon. And organisms that live there are periwinkles. I know you all know what periwinkle is all about. Many people eat it. So these are organisms that live in that terrain. Then number 2, habitat. Like I said earlier on, I said types of habitat. Number 1 is the aquatic habitat. Number 2 now is terrestrial habitat. The ones I mentioned before was types of habitat in aquatic habits. So now we have number 2, which is known as the terrestrial habitat. Terrestrial habitat is also known as land habitats, which contains animals and plants living on the land. Example of animals that live in terrestrial habitat, we have man, we have lions, we have tigers, monkeys, and so on. They are organisms that live in where? Terrestrial habitats. And then number 3 types of habitat, we have the arboreal habitat. And this is also known as air or tree. So animals that live on air and on tree are known as arboreal habitat. That is where they dwell because it's on air or on tree. An example of these animals or plants that lives there, number 1 example, we have the butterflies, the birds, the weaver birds. They are animals that live on the air. So these are the types of what? Habitats that we know. And these habitats, each organism that lives in this habitat, they have a features that helps them to adapt to that particular environment. Adaptive organisms features. And number 1, for aquatic organisms, for them to adapt in that habitat known as aquatic, the features they possess as following. 1, they have fins and tails for swimming. Without the fins and tails, they will not be able to swim in water because aquatic organism is known as water habitat. That is animals that live in water. So they must possess these features that will help them to adapt to that particular environment. Number 2, streamlined body shape for swimming. Streamlined body shape for swimming. So they must have that particular feature that will enable them to swim in water. Then number 3, tails and webs toes for swimming. These are features that makes them to adapt in that aquatic habitat. And number 3, they must possess gills for breathing. So animals that has gills are animals that will be able to adapt to that aquatic habitat. Swim bladder for floating. Swim bladder for floating. So these are the features for aquatic organisms to adapt in aquatic habitats. And so we have features for terrestrial organisms. Number 1, features. They have limb for locomotion. Number 2, lungs for respiration. And number 3, scales and hairs for protection and temperature regulation. These are the features they will possess that will make them to adapt to that particular environment known as terrestrial habitats. Known as what? Terrestrial habitat. Then we'll go over to adaptive features of arboreal organisms. Number 1, wings for flight. Any animals that are in arboreal habitat, they must possess wings for what? Flight, so that they'll be able to fly on the air. And number 2, clasped toes for perching and climbing. Number 3, small size to be able to remain in air. Small size to be able to remain in air. For example, bacteria, virus, they are so small in such a way that enables them to remain on the air. And then number 4, streamlined body and light bone for flight. So once this animal possesses these features, they are able to adapt to that particular environment known as arboreal habitats. And so if you are asked under this to give some adaptive features of a particular habitat, like the terrestrial habitat, the aquatic habitat, I believe you should be able to know that. So with these explanations so far, I believe you are able to understand what pollution is all about. And once you are called upon to answer any question on that, you should be able to answer it as a student. Thank you very much. I see you some other time. I'm by name Mrs. Ogala Blessing.